I'm Mr. Malden, and this is the Middle School Math Toolbox, where I teach you how to become a middle school math master. So if you're interested in that, hit the subscribe button down below. Today we're going over composite figures, the area of composite figures, which means if we have a bunch of figures like we see on the screen right here, and we were to put them together like that right there, all right, we're going to have to find the area of that funky looking shape, all right? So let's just kind of back up for a second and just talk about what that composite figure is. A composite figure is whenever you've got just kind of a shape that doesn't really have a name, kind of like that right there. There's no name for this, all right? And you end up, because you need to find the area of that, breaking it up into easily recognizable shapes, all right? So right here I've got a rectangle, a triangle here, I've got another rectangle, and I've got a semicircle down here. You take a shape that doesn't have a name, that's not a common shape, and you break it up into, and you separate it out into figures that do have names, that are common, all right? And then you're trying to find the area of that figure. And the way that you're trying to find the area of that figure is once you kind of break it up, all right, and you recognize the different parts, you can apply the formula for each of those parts. So for instance, that is a rectangle right there. So we're going to end up doing, area equals base times height. This looks like a trapezoid to me, or a rectangle and a triangle. So you could either separate it out into two different shapes right here, or you could, separate it out into two different, or just one shape, and that's a trapezoid, all right? Which would be area equals 1/2 base 1 plus base 2 times height. And then this one right here is a semicircle, which would be area equals pi r squared, and then ultimately we're going to have to divide that by 2, all right? So what we've done here is we've taken our figure and we've separated it out into easily recognizable shapes, and then we're going to apply the formulas for each of those shapes and finally add them all together. If it's kind of like this. We'll have an example at the end where we have to do some subtraction. But for now, we would add all those together because collectively they make up the area of that funky looking shape. Just like this one right here that you see on your screen. All right, if I were to separate this out, I see I've got a semicircle, I've got a trapezoid, and I've got a triangle right here. And if I put them all together, it looks like this funky shape that doesn't have a name, all right? So to be able to find the area of that funky shape that doesn't have a name, you really just need to find the area of the individual shapes and then add all that together, all right? So in this case right here, I have a semicircle, I have a trapezoid, and I have a triangle. And if I wanted to know the combined area, I have to find the area of each of them individually and then add them all together. So in this case right here, I'm going to take my workstation right here, and I'm just going to kind of separate it out. Because I have three different figures, I've got a half circle, I've got a trapezoid, and I've got a triangle. All right, so I'm going to separate my workstation out into three different shapes, because I know I'm going to have three different formulas right here in order to be able to find the area of that whole collective figure all together. So I've got the area of a circle. Area equals pi r squared. And then we remember that when we use that formula right there, we're going to find the area of a whole circle with a radius of 3, all right? But when we're at the very end, we understand that we have a half circle and not a whole circle, all right? So we're going to have to do a little bit of extra math on the back end, all right? This trapezoid, I'm going to use the formula for the area of a trapezoid. And then the triangle, I'm going to use the formula for the area of a triangle, all right? And those are the different formulas I'm using, all right? You can find those on a reference chart or reference page. A lot of times tests, if you're taking this on a test, it'll come with that reference page and you'll be able to see what those formulas are. And now we're just going to fill in the formula with the correct numbers. So pi would be 3.14, and now we're going to look for the radius. What is the radius of this semicircle? Well, the distance they gave you was from one side of the circle all the way to the other side, which is not a radius. That's a diameter, all right? And a radius is half of a diameter. So if the whole length is 6, The radius is 3, all right? Now I want to fill in this other one down here. I've got area equals 1/2. Base 1 is going to be the top. Base 2 is going to be the bottom of the trapezoid. And then our height, all right, is 5. It's straight up and down. And then the final one, we've got the triangle right here. The base of it is 6 and the height is 7. And now all I have to do is complete that math and I'll be able to find my answer. So let's go ahead and do that, all right? We've got 3.14 times 3 to the power of 2. Now I remember in PEMDAS, which is my order of operations, that exponents come before multiplication. So I need to apply this exponent first. 3 to the power of 2, that's 3 times 3, which is 9. 3 times 3 is 9. And then we're going to multiply that by pi. And I've just found the area of a whole circle with a radius of 3, all right? And the area of a whole circle is 28.26. Now, I need to make this mental recognition that I'm dealing with a half circle here and not a whole circle. Well, whenever you're dealing with a half circle or a whole circle, first you're going to have to find the area of the whole circle with a certain radius, and then you're going to have to, in this case right here, because it's half of a circle, divide that by 2, all right? And when we divide that by 2, we get 14.13, right? The next one down, 8 plus 12 is 20, half of 20 is 10, and 10 times 5 is 50, all right? And then the last one, half of 6 is 3, and 3 times 7 is 21. So then we can just go and add all these three numbers up together in order to be able to find the area of that whole shape, all right? So when we do that, we're going to kind of apply it on out, and we're going to add those together, and we get 85.13. That's how we would find the area if they were individually spaced out. But we put them together like this, all right? And my question to you is, if I had them separate and found the area here, and I put them together, did anything change? And the answer is no, it didn't. All I did was I just put the pieces together into forming, you know, an oddly shaped figure, all right? So, in order to be able to find the area of composite figures, you need to recognize that it's just a, you know, adding together all the areas of the easily recognizable shapes to be able to find the whole shape, all right? So you've got these different formulas that you're going to have to end up working with. If you have not found, or if you don't know how to find area of like a rectangle or a triangle or a trapezoid, I encourage you to go back and watch that other video, area of figures, all right, before you come to this one. But the area of a rectangle is base times height. The area of a triangle is 1/2 base times height. The area of a trapezoid is 1/2 times base 1 plus base 2 times height. And the area of a circle is pi r squared, all right? All of those solve the same way. You start with the formula, you fill in the formula with the right information, and you just do the math, simplify the math to be able to find your final answer, all right? So we just kind of remember that as we're going through this. And now let's just take a look at this picture real quick, all right? This is a shape that does not have a name, all right? It is not an easily recognizable shape. But if I took this and I separated it out, I could find some easily recognizable shapes. I've got a rectangle, I've got a triangle, in this case I have a quarter circle, all right? So I'm going to have to go through and separate out my, my workstation. I've got a quarter circle. And I'm going to remember that I'm going to have to find the area of a whole circle, and then at the very end I'm going to divide by 4. Why? Because it's just a quarter of it. It's not the whole thing, it's just part of it. But I'm going to have to use the formula for the area of a whole circle, which is area equals pi r squared. Then I've got a rectangle. All right, that's my rectangle, and that is area equals base times height. That was going to be pretty easy. And then I've got my triangle. That one is area equals 1/2 base times height, all right? I want you to pause the video and using the numbers that you see on the screen, see if you can do this one by yourself and then come back to see if you got the right answer. All right, so I'm going to go here, I'm going to put in 3.14 for pi, I've got my radius, which is the distance of the edge of the circle to the center, and that's what's given to me here, all right? It's not a semicircle where it gave me the whole length. It's a quarter circle where it gave me just a half length. So I am going to use the 4 right there to the power of 2, all right? So I've got 4 times 3.14 equals 50.24. That's the area of a whole circle with a radius of 4. So I'm going to now, because I'm just dealing with a quarter circle, all right, I'm going to divide that by 4, and I find that that figure, the quarter circle, has an area of 12.56. All right, the rectangle is pretty easy. It's 5 times 10, which is 50. And then the triangle also is fairly easy once you've got the right numbers. All right, we have 1/2. I know that the height is 4 inches, but I don't know what the base is. It didn't tell me what this base was, but it did tell me that the other side, the whole side of that rectangle, is 10 inches. And it also told me that the radius of this circle is 4. So if it's 4 this way, then it's also 4 this way, which then gives me enough information to be able to find that remaining piece. So if the whole side is 10 inches and part of it's 4 inches, then the other part has to be 6. So we can put the 6 on the inside of that. 6 times 4 is 12, and 12 divided by, 6 times 4 is 24, and 24 divided by 2 is 12. All right? So I found the area of each individual piece, and then I can just simply add those together. Add 12, add 50, and we come up with a total area of 74.56 inches squared. All right? Because we're dealing with units to the power of 2. It's squared. All right?
Teachers, I have 2 quick announcements. First, the bells are about to be turned off after they ring to
All right, we're back on. Here we go. Now, let's go ahead and do this one. I want you to see if you can do this one by yourself and then come back to see if you've got the right answer. All right? If you have already worked on this, then you can continue watching. If you have not, then I encourage you to go back and try it yourself. That half circle, we got to use pi r squared for the area. The pi is 3.14. The radius of that circle, or the half circle, is 3, because 6 is the whole length. That's the diameter. The radius would just be 3, all right, which would be half of that. So we got 3 times 3, and we're going to multiply that by 3 times 3.14, and that's going to equal 28.26, and that's the area of a whole circle with a radius of 3. So if we're just dealing with the half circle, we can divide that by 2, and we come up with 14.13 for that half circle. Then we've got a triangle, which is 1/2 base times height. So 1/2, 4.5 times 6. All right? Half of 6 is 3, and 3 times 4.5 is 13.5. And if I added together the 14.13 from the semicircle, both of those together are 27.63.
Can we go?
Just do one more, all right? So we're going to find the composite, or find the area of the shaded figure, which means we need to find the area of the whole rectangle, and then notice that the little piece has been cut out of it, okay? So I want you to try to find the area of this shaded figure by yourself, and then come back to see if you got the right answer. All right, I know that I have a big rectangle, all right, and I've got a small one. The area of a rectangle is base times height, so it's the same formula for both ones. The big rectangle is 12 times 10, which is 120. And then the small rectangle is 7 times 2, which is 14. All right? And if the big rectangle was 120 and we took out that piece, then we're going to subtract them. So 120 minus 14 gives us 106 meters squared for the shaded region. So we just have to pay attention to our shape that we're given. Separate it into easily recognizable shapes, and then if they're all joined together, add them together, or if a piece is taken out of a bigger piece, then take the bigger piece and subtract the smaller piece out of it, all right? If you have any questions, you can put those in the comments down below. We'll see you next time.